Some of you may be asking, well, what happens when each piecewise function is continuous, but the slopes of the tangent lines are not equal at the transition point? Well, when this occurs, we can still write the derivative f prime of x for each piece of the function. However, the function f of x is not differentiable at these transition points when the slopes of the tangent lines are not equal. Given the piecewise function, f of x is equal to 2x to the third plus 98 for x values less than or equal to 2, and it's equal to 5x plus 1 quantity squared minus 7 for x values greater than 2. Determine whether or not f of x is differentiable at x equals 2. Well, we know that both of these pieces individually are indeed differentiable, so we can find the left and right-handed limits of them to see if they are equal for when x approaches 2. So the limit as x approaches 2 from the left is going to be 2 times 2 cubed plus 98, which is going to equal 114. And the limit as x approaches 2 from the right is going to be 5 times 2 plus 1, 11. Square that, 121 minus 7 gives us 114 again. So because both the left and right-handed limits are equal to one another, this function is continuous. And since the function is continuous, we can find the derivative, and the derivative of the top section will be 6x squared. The plus 98 cancels out, and that's for x values less than or equal to 2. And then the derivative of the bottom section will be 50x plus 10, and that's found. You can use the product rule or power rule and chain rule, so we would have 2 times 5x plus 1 raised to the first power times the derivative of what's inside of here, which is going to be 5, and then the derivative of minus 7 will be 0, so we can ignore that. And then if we multiply 2 and 5 together, we get 10, and then we have 5x plus 1, and then if we distribute through, that's how we get the 50x plus 10. Now that we have the derivative, we can determine if the slopes are equal by substituting x equals 2 into both sections and evaluating. So we would get 24 for the top section, and we would get 110 for the bottom section, and these two values are not equal. Since the derivatives are not equal to one another, f of x is not differentiable at x equals 2. Therefore, f prime of x is rewritten to not include that x value of 2. So we write it as f prime of x is equal to 6x squared for x values less than 2. Basically, we remove the equal to part. And then the second section will be 50x plus 10 for x values greater than 2.